Okay, today we're going to get to learn how to do operations with radical expressions like add, subtract, multiply, and divide them. So one thing that's really helpful to note is that like radicals are radicals that have the same radicand. Okay, so remember radicand is just that number underneath the radical. When you're trying to combine like radicals, you just combine them the same way you combine like terms. Okay, so if I said simplify 4 root 3 plus root 3, you could think of that like, let's just pretend x equals root 3. Then we're really just doing 4x plus x, okay? And then remember, that's just 1x, so we get 5x. Hey, but remember, we said x was root 3, so we get 5 root 3, okay? And you don't really have to go through all that business of putting in x equals root 3, but let me just give you another example very quickly. If I said 9 root 2 minus 6 root 2, again, these are like radicals because they both have root 2. When you subtract them just like you're combining like terms, so not like 9x minus 6x, it's going to be 3 root 2. Okay, we're going to do things that are slightly more complex, but same concept. Okay, if I ask you to simplify something like this, 8 root 5 minus root 45, it's a little more complicated because right now, as you see them, they're not like terms. They're not like radicals because one has root 5 and one has root 45. So what you want to see is there any way you can make these like radicals or not? And yes, if we learn if we use our simplifying radicals from the other day, we can simplify root 45 because it has a perfect square that goes into it. 9 goes in. So remember, that's the same thing as root 9 times root 5. Root 9 is 3. So that is 3 root 5. So you're solving the problem 8 root 5 minus 3 root 5. Okay, now this looks a lot better because these are like radicals. And 8 root 5 minus 3 root 5 is 5 root 5. And you're done. Okay, so we got add, subtract. Now we're going to deal with some multiplying right here. So simplify root 5 times the quantity root 8 plus 9. Okay, so we're going to be using the distributive property to solve this problem. Okay, so root 5 times root 8. Hopefully you remember this property from, I can't remember what day, but root AB equals root A times root B, or root A times root B equals root A times B. So to do root 5 times root 8, all we're going to do is root 5 times 8, or square root 40. Okay, and then to do root 5 times 9, those are not both under radicals. The best way to write that is just 9 times root 5. Okay, and then we just have to check, are there any perfect squares that go into 40 or 5 to simplify this down? 40 does have a perfect square that goes in. 4 does. So that's 4 times 10. So the square root of 4 is 2. Square root of 10, we don't know that exactly, so we're going to leave that square root of 10. And then we have plus 9 root 5. 10 doesn't have any perfect squares that go in other than 1, neither does 5. Therefore, this is as simplified as it can be because these are not like radicals. One has a root 10 and one has a root 5. We can't simplify it any further. We're done. So 2 root 10 plus 9 root 5. Okay. Take that last step a little bit further, okay, and we are going to be multiplying binomials. So we're not going to multiply these any different than we've ever done before, but they're just going to have radicals in them. So I'm going to do FOIL or distributive property, George, whatever you want to call it, but I'm going to do root 6 times root 6. For now, I'm just going to write out what I'm doing. Okay, and then we'll actually simplify this later. Eventually, you're going to get really faceted and you'll do it more in your head. But here, then what I'm doing is plus root 6 times root 21. Okay, and then here, it's minus 3 times root 6 times root 21. And then last, minus 3 times root 21 times root 21. Okay, now one thing that you could do, when you're multiplying root 6 times root 6, I hope you notice it's just 6 and you don't actually go through the trouble to do 6 times 6 is 36, root 36 is 6. When you multiply a radical by itself, like anything, square root 5 times square root 5, you're going to get 5. Square root 10 times square root 10, you're going to get 10. So that's good to know. Here we don't know that, but we're going to do 6 times 21, because we can't do anything too much more simplified yet. So that's plus root 126. We'll have to simplify that later. But then minus 3 times root 126. And then here, minus 3 times, again, root 21 times root 21, that's just 21. Okay, we're definitely not done. We've got a little bit, a good ways to go, actually, I would say. Okay, so I would probably go ahead and simplify my root 126. I'm going to look for any perfect squares that go in there. 9 goes in, so I'm going to do that. If I divide 126 by 9, and then hopefully I get 14 if I did that right. Let's see. Yeah, 14. Okay, so it's going to be root 9 times root 14 minus 3. This is going to be, again, times root 9 times root 14. We know root 9 is 3, so that's 3 root 14. This, again, 3 root 14. So this is 3 times root 14, so 9 root 14. And then simplify here what I know. So 3 times 21, 63. And then this is 6. Okay, so now I'm going to combine all the like terms I have and try to get this as simple as possible. Here's 6 and a minus 63. Those are like terms, so I've got negative 57. And then positive 3 root 14 and minus 9 root 14, that makes negative 6 root 14. These are not like terms. I'm done. Okay, and remember how I talked about you might want to put this into your calculator and this, and make sure they give you an equivalent decimal expression. I think that would be probably very wise to double check, because there's a lot of steps and places to mess up. Okay. All right, let's talk about conjugates. Conjugates are the sum and the difference of the same two terms. For example, if I had root 7 plus root 2, and then I had root 7 minus root 2, those are conjugates because they both have root 7 and root 2 as their two terms. One's plus, one's minus. Okay, so we're going to multiply these conjugates and observe what happens. And then I'm going to ask you to try to make up your own pair of conjugates and multiply them and see if you notice anything that's happening. So let me get a new fresh paper there, but I have root 7 plus root 2, the quantity, times root 7 minus root 2. Okay, so again, I'm going to start doing distributive property. So root 7 times root 7, I could write that down, or I know that's just 7. Okay, here, root 7 times root 2 times a minus root 2, that's going to be a minus root 14. Here, root 2 times root 7, that's going to be a plus root 14. Okay, and here, root 2 times the negative root 2, that's going to be a minus 2. Root 4, which is just 2. Okay, so now I'm going to combine my like terms. Okay, and I see 7 and a minus 2, so that's just 5. And I have negative root 14 and positive root 14. That's just 0. I don't need to have it. It's just 5. Okay, so try your own pair of conjugates and see if you can figure out anything cool that's happening. Okay, what I want you to notice is that when you multiply a pair of conjugates, even if they have all these radicals in them, at the end you get something that has no radicals in it, which is really convenient when we're trying to do stuff like rationalize the denominator. So that's what we're going to do next. Okay, so if I ask you to do something like this, simplify 8 over root 7 minus root 3. So let me get a new piece of paper for that too. Okay, 8 over root 7 minus root 3. Before, we were just had like one simple radical on the bottom, and it was kind of easy just to multiply by it as the sneaky form of 1 on the top and the bottom to rationalize your denominator to make it so it had no radicals in it. Here, when you have this more complex expression, multiplying it by root 7 minus root 3 is not actually going to end up getting rid of our radicals. But based on what we just learned with the conjugate, if we multiply it by root 7 plus root 3 to the top and the bottom, so remember, hey, this is a SFU, it's a sneaky form of 1, I think I'm going to be able to rationalize the denominator. Okay, so I'm going to start here. I'll put this in parentheses because I think it's just going to make it all a little prettier for me. So on top, I'm going to distribute. So I've got 8 times root 7 plus 8 times root 3. On the bottom, I'm going to use distributive property again. So root 7 times root 7 is 7. Root 7 times root 3 is plus root 21. Negative root 3 times root 7 is minus root 21. And then negative root 3 times positive root 3 is just negative 3. Okay, so again, these two terms cancel out, and I have 7 minus 3, which is 4. Okay, so now I'm just trying to simplify this. 8 root 7 plus 8 root 3 all over 4. I can simplify that a little bit because both of these divide by 4. There's a common factor there. So I could divide both parts by 4, and I'm going to get 2 root 7 plus 2 root 3, and I'm done. And again, if I were you, I would definitely go on my calculator, especially on a test or a quiz, and make sure that these two expressions are really equivalent. Okay. Last one to do. All right. So a painting has a length to width ratio of that's approximately equal to the golden ratio, which is 1 plus root 5 over 2. So the golden ratio is this ratio that they say in art and humanity people think is the most beautiful. So 1 plus root 5 to 2 is this ratio. The length of the painting is 51 inches. You're going to find the exact width of the painting in simplest radical form. And then you want to find the approximate width to the nearest inch. So I'm going to start this out. I know that 1 plus root 5 over 2, that's my length to width ratio. Okay, so I want that to be equal to the ratio of my painting, which has 51 over x. I do not know what x is. That's what I'm trying to find, the width, w, whatever you want to call it. Okay, so the first step you want to do is make a proportion like this. Second, you're going to want to try to solve the proportion. I highly recommend cross multiplying here. So we're going to do x times 1 plus root 5 equals 102. Okay, to get x alone here, since it's being multiplied by 1 plus root 5, I could divide by 1 plus root 5 to both sides. Okay, that's gone. And I'm going to go above. So I'm going to have x equals 102 over 1 plus root 5. Okay, that's a great answer. Okay, I should not say a great answer. It's an okay answer, but this asks you to find it in simplest radical form. So the problem I have here is there's a radical in the denominator, so I want to get rid of that. So I'm going to multiply by the conjugate here. So I'm going to multiply by 1 minus root 5 over 1 minus root 5. Okay, so on the top I have 102 times 1 minus root 5. On the bottom, so that's, I'll put this on parentheses, that's 1 minus root 5 plus root 5, those are going to cancel out. And plus root 5 times minus root 5 is going to be minus 5. So on the bottom, that equals negative 4. Okay, now here, I can simplify this. I can't make it a whole number, but I can make that as negative 51 over 2 times 1 minus root 5. Okay, so then I'm going to have negative 51 plus 51 root 5 all over 2. That would be my answer in simplest radical form. Then I would, of course, it asked me to write it as a nearest inch too. So it's going to be negative 51 plus 51 root 5. I would highly recommend using a calculator for that. And then dividing it by 2. And I get about 31.5. It asked me to find it to the nearest inch, so I'm going to say about 32 inches. And I need to see if that seems reasonable. I think it does because it should be shorter than the length in this case because of the ratio. And 32 inches seems relatively reasonable. And of course I could double check it by actually plugging it into this proportion and make sure both sides match. All right, so a lot of work to think about here. We'll practice more in class.